Good afternoon, everyone. My name is Alexei. I'm here today with my colleague Zuda, and we are both coming from a company which is called Uniper. And we are very happy that you joined us today and give us an opportunity to share our experience with you. We are going to talk about the Flink usage for energy and commodities trading business. And the focus would be not so much on the technology or architecture, but we'll try to explain you why a company like ours has the need in general to use technologies as Flink, and what are the major drivers for that. But obviously, we are happy to demonstrate some concrete examples of how we benefit from the Flink usage. So let's start with the company itself. What is Uniper? Uniper is the #5 biggest company in Germany, as for the revenues, as for the result of the previous year. It operates in the energy domain, and headquarters are located in Düsseldorf. You shouldn't be confused by industry statement here. It says it comes from electric utility, but Uniper, it's not just a power station or power stations, it's much more than that. Uniper covers the whole life cycle of energy production, and this life cycle starts with obtaining respective resources to produce energy. It goes about coal, gas, oil, many other resources which needs to be obtained to generate energy and heat. And Uniper obtains these resources for own consumption, but Uniper is also very active in trading these resources with other companies on open market, and we'll tell more about that. Once you have resources, you need to deliver them to the manufacturing facility itself, to the power station. And Uniper operates own logistical infrastructure and storage infrastructure for that. And eventually, Uniper runs power stations where energy is being generated. And we are talking about absolutely different types of power stations. Conventional power stations where coal is being used, gas power stations, nuclear power stations, and different types of renewables, hydro, solar, etc. What is worth mentioning, the company target is to become absolutely carbon neutral by 2040. So to continue with the same, for you to get understanding what is the scale of company operations. Yeah, if you are talking about the areas where the company is extremely strong, it goes about power generation and gas trading. In terms of power generation, the total capacity of power stations which are being operated by Uniper is enough to approximately satisfy the needs of 30 million of people. Like we are talking about the normal domestic consumption. And power stations are located in 5 different countries across Europe. Another area where Uniper is especially prominent is gas trading and supply. So on the peak, company satisfies up to 50% of the total gas supply in Germany. And as I already mentioned before, Uniper operates own storage facilities which are being used not only by Uniper, but by other companies as well. In scope of export trading activities, when it goes about commodities trading, which I mentioned before, not only gas, but all the rest which company uses in operation, a company collaborates with partners basically across the globe in 40 different countries. So given the scale of operations, we can assume that the company has significant level of social responsibility and is basically subject of national security to some extent. Company customers are big companies, so Uniper doesn't operate on the retail market. Coming closer to the automation. So for a company like Uniper, given the diversity of business activities, there are 2 major areas where we are talking about routineous need to process data in the big scales: sales and trading and assets management. Company is very assets rich. Just one single power station contains hundreds of thousands of different components, and they need to be supervised, monitored, updated regularly, maintained. In different presentations yesterday and today, you already heard a lot about things like Internet of Things, preventive maintenance, predictive maintenance, etc. That's exactly where it belongs. But it's another very diverse and very interesting area. We are not going to touch it today. Today we are talking about sales and trading IT. I'm just mentioning about assets management so that you have understanding that for a big energy company like Uniper, it's quite typical to have absolutely different areas where automation is topical. Continuing with sales and trading. So before we proceed further with automation, let's talk a little bit what is that and what are specifics. So when probably someone hear the word trading or company trading, you have pictures like that in mind, yeah? So like stock exchange where companies meet, represented by brokers, people are shouting, running. When it goes about commodities trading, it looks actually like this. So all the collaboration is done remotely. So traders, people who have official title trader, they collaborate with others via exchanges only remotely. And obviously, they are hugely reliant on the correct data. So speaking of typical challenges for sales and trading business in commodities exchange, there are few fundamental challenges which needs to be kept in mind when we are talking about automation. First of all, it's huge diversity of the time horizon. When it goes about the power trading, a company might have an obligations to enable energy supply within single minutes if the company is urgently asked by a grid operator to help to balance the country energy supply in total. Decisions should be taken within minutes. When it goes about contracts to obtain required resources like gas, company can go in very long-term contracts, few years. In some cases, it stretches up to 20 years. And all this planning should be kept in mind. And that's exactly where we are coming to the need to constantly balance and optimize. Because given the scale of company operations, we can say we don't have that many events, but the cost of one single event is that high that any mistake cannot be tolerated. And companies constantly looking for an opportunity to optimize the balance in terms to match responsibilities and available capacities. If just we talk it through it like in simple terms, what it means. You have a client, like some industrial company in Germany, which has their own manufacturing plants to produce something, and they buy from Uniper specific amount of energy. And this contract can stretch across a few years, and this contract is quite flexible. So for instance, this month you are supposed to supply this amount of energy, then for a week less, then for 2 weeks more, and then you have this granularity of events, and you keep this information in your systems. To produce this energy, you need to have enough resources. And that's always a balance and a trade-off, because if the company produces too much energy, it's not good. If not enough energy, it's also not good, because if company is not able to supply the energy which is committed to be supplied, that's a subject of serious violation, because the network operator, another company, which manages like electricity grids in the country, in Germany, would have to get this energy from somewhere else, and then will penalize Uniper for the obligations which are not met. And speaking of resources, same thing there. If you don't plan well enough, if you buy expensive gas, and then you produce energy which you cannot sell with a high price, you have sustainable loss. And again, coming back to the cost of these operations, we are talking about really huge numbers. And this all is accompanied by the huge dependency on the global events. Given the companies operating across the globe, whatever happens, like for instance, Russia invades Ukraine and cuts off gas supply to Europe, and all your 20 years planning ahead is gone. Then within few months, you have to replan everything, find new suppliers, and obviously it comes with a cost. So speaking about the IT landscape behind it all, obviously we are talking about a huge number of different groups of applications which are being used across different steps of the trading life cycle. It starts with the access to the external markets. So a company has access to many exchanges across the globe where traders meet and launch deals. And then this data flows into the internal systems where all the books are being maintained. We have sales applications where typical CRM activities being done and so on and so forth. And this all is connected to the actual production systems which are being used to manage power plants and so on. Core and fundamental requirement here is to keep this information intact and to keep this information synchronized. So we cannot allow ourselves to have discrepancy, at least on the critical path of the decision-making for trading activities. Coming closer to Flink. If you just look back a few years, in approximately 2019, majority of data flows between those applications mentioned before, they were very straightforward. Point to point, just move data from source to consumer, that's all, not so much of transformation. But given that we are naturally growing, given that market is changing, and sometimes we have some events which are accelerating trading activity significantly, we couldn't allow ourselves to continue living like that. So data availability needs increased, number of events increased, things like automated trading came in place. So currently, significant portion of trading activity it's not being done by a human being. It's done by application which is following determined parameters, and only final acceptance is done by a respective trader. And the speed of changes which occurred in our area was that high that it was very costly to continue implementing that in the core analytical applications which we have in our landscape. And we naturally had to find a way to use some technologies to fill in the gaps between these analytical applications. And that's exactly how we met Flink. In our implementations, we are trying to standardize the way how we implement and the technological stack which we use. So with that, I will give the word to my colleague Zuda, and she will provide you with information on how exactly it's happening and with some examples. Over to you.
I'll just go into the details of where we are on how our landscape is looking like. So we have energy markets, or the exchanges, and we have our risk systems, and we have algo tradings and our dispatch and all other systems. So each is all different systems of different flavor, because few systems are older from risk point of view, and few are newly, like algo trading is very common in the recent years, so it's a new one. So there needs to be a gap, or bridging the gap between the old and the new systems and the way we operate and produce the data. So that's wherein Kafka is one of our main backbone for message transfers. And also Flink, I think we are using Ververica platform as such for our implementation. Mainly the data streams APIs are being used, and we use microservices also, connectors for our different use cases, function apps, and others. So it's not one solution for all. Based on our requirements and others, we do have the flavor of across the technical stack that we are using. So this is high-level functional overview of what we do. And why did we choose a Ververica platform? I think we started our journey in 2019, 18 more or less, I think, and then 19 was, okay, let's use the real-time or data streams APIs. And one thing what we found was, okay, Ververica platform, it was providing a platform for us, and a few things that was really helping or that was eye-catching for us to choose was the automated checkpoint and automated save point that helps us for any recovery easily, and RBAC that comes for the enterprise security, and user experience for the operations support, and it has a web UI and REST UI options. These were the few considerations, and we were a very small team of technical where we couldn't start from scratch, and the platform provided at least the baseline what we needed, and we were able to do our business specific functionalities rather concentrating on our platform. So going back to one of the use cases where it sounds simple, but it really made a difference for us. One is the systems can generate duplicates in a near world of near real time. The duplicates can cause problems at the end users level also. So that's the point here. So a system, end of day, when you're generating your reports or anything, it can, or even when you trade it, it can generate the same message and again. On a real-time basis, there was a need to identify such duplicates, eliminate it, and just send the unique ones to your downstream systems, because when you have a normal RDBMS or the relational database-based systems, you would need something in between to bridge the gaps, because the uniqueness, when you do a parallel processing, uniqueness cannot be maintained on DMS. You can do out, you have a latency in there. So to address this, we started using Flink. And especially in the processing, we use state also, because there was a millions of records that were sent within a short span of time. In case if the ingestion has to happen as well as the processing in real time, but more or less, and sending the messages, unique messages to the systems. So in this way, I think it sounded simple, but with this duplication framework that we had it, we were able to achieve around, I think the initial, our complete process was taking 12 hours end to end to do it, and it was just reduced to 6 to 4 hours, giving us ample amount of time to take it forward. It was, and it also reduced the complexity, because 12 hours meaning that if something in between was happening in system A, the previous process was redoing entire thing from scratch. So that meant it was rerunning multiple times, but here we were able to batch it so that we don't batch the entire 12-hour process, but rather it was based on a certain amount. I think we were able to reduce it, and it provided a basic business benefit on it. So that's and we use state also, because in case if your Flink reaches or your job reaches the high time of memory, it goes in for auto restart, and with a restore strategy and proper thing, automatically it starts from where it left, and our process was always exactly once. So we had to send the message only once across systems. So this is one of the use cases we have it. The next one is a bit more complex one, where we were, I think, in the data streams APIs, we were almost using all the functionalities that are available with respect to state, as well as the functions that are available. So here the use case or the problem statement was, okay, a system sends us multiple messages. It can send us the instructions on how to aggregate a message, and also it has a mapping criteria on which message should be mapped to which instructions. So it comes in 3 different flavors to the Kafka, and the need was, and the messages can come in any order. The instructions can be from today to any day in future. As you saw in previous slides, we have a balancing, so it is a short-term and long-term. So based on the requirements, the instructions can be on any flavor for any extension period of time, and it can come anytime, and it can also get changed. The instructions today, you're telling that a particular message has to be aggregated in certain way. Tomorrow, immediately you can change it. Oh, I need it in a different phase. So in that way, it's so dynamic, and the end result is the system B should receive these aggregated messages in near real time. That is few latency, 1 to 5 minutes or maximum 15 minutes is the time expected based on your criteria. So for this, what we have done is we segregated. I think what we have done is we have implemented 2 types of things in our implementation using the data streams API. That is the topic, the assigning of the instructions and the mapping criteria to the messages, mapping it, and is done by the Flink processing. And then we also hand it over to the aggregation engine, because aggregation engine is not today. It's also today plus tomorrow plus day after tomorrow. So it has to continue. So that state is maintained. It is more like a state we are maintaining using RocksDB. And I think the aggregation is happening using I think more or less we are using 3 states. Majorly is the broadcast state, value state, and the list state for, I think, value state and the hash map state, I guess. I don't remember exactly. So these states are being used for our aggregation, and we produce the results to the system B. Yes, we do have alert notification, and we have a monitoring in place for Prometheus and Grafana. So these are the two use cases I would like to present, and I have 10 more minutes. Happy to take questions.
Hey, great talk. Do I understand correctly that in this join of multiple streams with a broadcast site as well, you're actually kind of creating this dynamic rules engine, which means it accepts some rules of processing from outside, and then it does in process multiple of two transformations?
Yes.
Is that correct?
Yes, that's correct.
Great.
Thank you for the question.
I know, I implemented and I know how hard it is.
Thank you. I think it's good.
Thank you very much for listening. If you have any other questions, happy to catch up later to talk about sales and trading, and not only. We mentioned assets management, can provide with more data about that side as well, if you need that. Thank you so much. Have a nice day.